industrial purpose. Okay, so that is the YouTube manometer. And so YouTube manometer, except the YouTube manometer, there are other variants of manometers that are available. So that is the inclined limb type manometers, ring balance type manometers. That is the inverted, that is the bell type manometers. Okay, so basically in industry that inclined lane type manometer is mostly preferred. Okay, and ring balance type, these are the inverted bell type manometers, the YouTube manometer, these are basically the mostly laboratory based instruments. Fine. So you know that the basic what is the manometer actually, YouTube manometer. YouTube manometer is basically that if you see this diagram in the first diagram, so this is the vertical tube. Okay, there is a vertical tube, right? And there are basically the two limbs. This is the first limb and this is your second limbs. The first limb and second limbs and same cross sectional area. You know that. So first initial case, we know that suppose these two limbs, if these are the open, first we have considered this is the first open to the atmosphere. These two limbs are open to the atmosphere. Okay. So that means we are not putting any pressure inside it. Okay, we are putting some. Suppose we are filling some manometric fluid, heavy manometric fluid. So as these two lanes are open, okay, so that's why the level will remain same. It will reach in the same zero mark. Okay, here it is shown that is a zero mark. Okay, in the both the lanes, level will remain same, right? In both the lanes. Now, in this case, the pressure is zero. So now this tab, which is the first limb, left limb, is connected to suppose in the some pressure line. Okay, some inlet pressure line. Okay, some pressure is applied. Okay, some pressure is applied. Okay, so then what will happen? You know that when the pressure is applied, it forces down the fluid. Okay, the manometric fluid is forced down, right? So level decrease. The level height of the manometric fluid is decreased in the first limb, and the right limb, the height of the manometric fluid it obviously rises, that is increases. Okay, so now how to measure this pressure, how much pressure we are applying? That is simply because the pressure basically is measured, pressure basically based. Okay, pressure, that is P. Suppose here the 6 centimeter difference in height, the has been shown the 6 centimeter different height is different as 6 centimeter. So some centimeter of Hg mercury. So that is your gauge pressure. Okay, some millimeter. So that is your gauge pressure. So now if you add some rho into G, that formula H rho G, then you can get the actual pressure, that is kg per centimeter squares. Okay. So this is the basically the we know that working of the, that is the YouTube manometer. So thus we can measure it, the absolute the pressure, gauge pressures. Okay, how much pressure exerted, okay, inside that tube, that is you can calculate. Okay, using that formula we know that measuring the sums very easy, that measuring you have to measure the calculate the height difference. Okay, because the pressure actually is expressed in terms of millimeter of Hg or centimeter of Hg. Okay, that's the vertical height, right? But actually, what is the basic disadvantage of this? You know, that is a YouTube manometer. That's why basically the vertical manometer. That's why it is not used in the industry purpose. Because suppose this is a YouTube manometer. Okay, it's a vertical tube. It's a vertical tube, right? So when the level, suppose the pressure, the height difference is very small. Suppose the height difference is very small. Okay. So suppose in the left limb, in the left limb, the height is there. Okay. In the right limb, the level rises. Suppose level rises up to this much. Okay. So this is the height difference. Okay. So this is the height difference. Okay. So this is the height difference. So it is very small. Okay. It is very small. Okay. So if you want to measure the height difference, okay, so it will face some difficulty. Okay, it will face some difficulty to measure the height difference because it's very small. Okay, you will not be getting some accurate results accurately. Okay, but particular height difference, what is the height difference? Okay, you can't measure it. Okay, so perfectly. Okay, so that is actually the disadvantage of this vertical type manometer, or you may say YouTube manometer. Okay, so that's why to overcome that problem, you have to go for the inclined manometer. Okay, you have to go for the inclined manometers. Okay, inclined manometer is the better choice. So that's why it is used in industry. In some our real life, basically inclined manometer you can see in mines. Okay, in mines the inclined manometer is used to measure the pressure in that fluid, something. Okay, in mines. So mostly it is used in inclined manometers. Okay, because it's very difficult to use the vertical U-tube manometer. Okay, so that's why this type of manometer is for laboratory test instrument. Okay, it's not preferred in for industry purpose. Okay, industry purpose, if for industry, then you have to choose the inclined manometer. So inclined manometer actually, if you see the diagram, and now I am showing you just to see it. What is the inclined manometer? Inclined manometer is there is a one limb, okay, another limb is inclined, okay, another limb is inclined. Suppose this is your first limb, this is your first limb, okay, first limb like vertical, another limb is inclined, another limb is inclined. Okay, so both the limbs are the same cross-sectional, both the limbs are the same cross-sectional area. Okay, both the limbs are same cross-sectional area. Now, first consider the first case. First consider the first case when there is no pressure, means they are open to the atmospheres. Both the limbs are open to the atmospheres. Okay, so in that case, what will happen? In that case, what will happen? The manometric fluid you have inserted. Okay, you have put some manometric fluid inside the manometers. Okay, and suppose the level in the both the limbs, the level in the both the limbs will remain same. Okay, both the limbs will remain same. The level is same. Okay, in the both the limbs, the level will remain same. Okay, so now what will happen? Now what will happen? If this suppose is this channel in this limb is connected, suppose to a pressure line. Okay, suppose it's connected to a pressure line. Okay, suppose it is connected to a pressure line. Okay, this is the inlet pressure point. Okay, this is actually inlet pressure point. So some liquid is here, some manometric fluid is there. Okay, manometric fluid is already inserted. There are some density, different densities there. Okay, so suppose if you are putting some liquid, okay, liquid is included. Okay, some liquid is included when you have some different density. Okay, so when the liquid liquid you have inserted, that means it is some pressure. Some you are applying some pressure. Pressure is exerted. Okay, so it force the manometric fluid to go down. Okay, so level क्या होगा? Level decreases in the first limb. Okay, and the level rises in gram. If you see the second diagram of the inclined manometer for the case 2, okay, for the case 2, so if the pressure is applied here, suppose there is some pressure line. Okay, this limb is connected to a pressure tap. Okay, the pressure is applied. Okay, so level, this is 0 level. Okay, so down the level some decreases. Okay, level decreases. Okay, from this level to this level decreases. Okay, and in the level in the another limb increase. Level in the another limb is increases. Okay, so obviously there's some height difference. Okay, you can measure some height difference. Okay, so now if we join this reference line first, okay, so join the reference line means this level same. Okay, means at this point pressure, suppose consider karo this is the P2. Okay, suppose consider karo this is the P2 and this is the P3. So this P2 and P3 means this point and this point. Okay, this pressure same. Okay, P2 equals to P3, right? But you have to measure what? You have to measure the P1. You have to measure this P1. Okay, you have to measure this pressure. How much pressure exerted? Okay, so now we have considered this level is same. Okay, so pressure at this point and pressure at this point are same. Okay, but now how to measure the height? Actually, that is the advantage of this inclined manometer. You will be measuring the height here indirectly. You will be measuring the height here indirectly by measuring the length. This length, okay, this length suppose consider karo L hai. Okay, there is some scales or whatever scales. Using that scale, you can measure this length. Okay, but after measuring the length, suppose consider karo this is your ground. Okay, this is the ground. Okay, this is your ground. Suppose this angle is your theta. This angle is your theta. So obviously we can consider this angle is a theta. Okay, so now this is your height, that is h. This h we have to measure indirectly, right? So now how will you measure? If you know the value of L, if you know the angle, okay, if you know the angle, this inclination angle, okay, if you know the angle, then easily you have to apply the trigonometric formula. That is how, that is what, h by L, that is equals to what, sin theta. H by L, that is equals to what, sin theta. Okay, so this is the formula. So if you know the value of the L, if you know the value of the theta, then you can easily find out the value of the H. Okay, तो यहाँ पे एडवांटेज क्या हो रहा है मेरा, व्हाट इज द डिफरेंस क्या हो रहा है मेरा वर्टिकल से और इंक्लाइंड में, डिफरेंस क्या हो रहा है, व्हाट इज द डिफरेंस? Difference is that vertical, in the case of vertical U-tube manometer, you have seen in the vertical U-tube manometer, in this manometer, when the level height difference is very small, it is very difficult to measure this height. Okay, del h, it is very difficult to measure this height. So now if this limb is inclined, this limb is inclined means you can measure the length first. Easily you can measure the first this length. Okay, how much level rises, then you can measure the first length. Okay, so after measuring the length, and if you know the angle, okay, so then you can easily find out the value of h indirectly. You can measure the value of the h. Okay, so if you suppose this angle is suppose 60 degree. Okay, if you decrease this angle, okay, if you decrease this angle, okay, then what will happen? The value of the L will increase, but you will be getting the more accurate result, you will be getting the more better results, satisfactory results. Okay, so that is the advantage of the inclined type manometer, okay, over the vertical type U-tube manometer. So that's why, because of this, the inclined type manometer is mostly preferred, is used in the industry. Okay, that is more accuracy. It provides that is more accuracy result. So if you, how to find out that pressure here? How to find out the pressure here? Okay, suppose consider karo pressure at the point P2 and the pressure at the point P3. Okay, so this is equals. This level is equals. So we can write that P2 that is equals to P2 that is equals to P3. P2 equals that is equals to P3. Okay, so now how to calculate it? You know the pressure. You have to calculate the pressure. So that is P1 in this side. That is P1 plus if you know this height. Okay, if you know this height, suppose this is your H1. If you know this height, this height is known, H1. So H1 into rho means the density of the liquid, into G, that is equals to what? That is equals to what? P3. P3 means what we can write? That is P3 means, suppose this is the open to the atmosphere, this limb is open to the atmosphere, right? So we can neglect this, that means we can assume it's 0. Okay, suppose this is your P4. Okay, that is your P4. Okay, so P4 is 0 because it is open to the atmosphere. Okay, that is 0, but we can assume that is 0. So that is 0 plus what? 0 plus H2, 0 plus H2 into rho m into G. Okay, what is the rho m? Because rho m is the manometric fluid that is already filled earlier. Okay, manometric fluid is there. Okay, then there's some gases is inserted or some liquid is inserted, whatever. So there is some another density. Okay, that's why P rho is the density of that liquid and rho m is the density of the manometric fluid. Okay, so H2 into rho m into G. So now you can find out the value of the P1 here. P1 equals to what? H2 minus H1, H2 rho mg minus H1 rho into G. So how do you find out this H2? We know that H2 equals to L into sin theta. If you know the value of the L, you can measure the value of the L. Okay, so you can easily calculate the value of the H2. Okay, so indirectly, so that is H2 equals to L into sin theta. We can replace that H2 equals to L into sin theta into rho m. If you know the value of the manometric fluid, the density, and G, whatever, so then you can ultimately find out the exact pressure, this amount of pressure. Then you can calculate it. Okay, so that is the P1. Is it clear? The difference is clear? Difference, is it clear?
So could you just explain the difference again?
Yes. Explain again.
Yes, sir. Yes, sir. One more time.
Okay, one more time. Fine. So what you have first thing that in case of the U2 manometer, you have seen that in the vertical, there are two limbs are verticals, right? There are two limbs are vertical. Okay, both the limbs are vertical. Okay, first they are open to the atmospheres. Try to understand one by one. I am explaining. Okay, so first they are open to the atmospheres. So open to the atmosphere means no pressure is there. Okay, no pressure is applied. Okay. So if we some fluid is inserted, okay, if the fluid is included in the both the limbs, so level will remain same in the both the limbs, right? So now what will happen if some limbs, one limb is connected to a pressure line, okay, left limb is connected to a pressure line, right? So now the pressure is applied, okay, pressure is applied through this channel. So obviously it forces down the magnetic fluid, the level decreases in that limb and level some increases, okay, little bit increase. Suppose we consider little bit increase, okay, little bit increase in the right limb, okay. So this is the height difference, okay, because the pressure you have to calculate the pressure, you have to measure the height difference, right? So suppose what is the disadvantage of this vertical type YouTube parameter? Suppose the height difference is very small. Okay, so you can measure the accurately. That in that case, you can measure it accurately the height difference. Okay, so now what we will do? How to overcome it? How to overcome it? This right limb should be inclined. Okay, this right limb should be inclined. This structure, this right limb should be inclined. Okay, so this is the inclined type manometer. Okay, in the initial case, if you see in the inclined type barometer, in the initial case, when there is no pressure line, there is no pressure line. Okay, so no pressure line means dynamic fluid in the same in the both the limbs at the, will remain the same level. Okay, but now when the one limb is connected to a pressure line, okay, some pressure is applied. Okay, means we are applying some any service, liquid, gas, whatever any service we are applying. Okay, some pressure is there. Okay, so that is suppose P1. That is suppose P1. So P1 actually you have to calculate. Okay, this pressure is exerted. Okay, so that means the level decrease, that level decrease, that level decrease. Okay, from 0 level to this level decrease in that limb, and in that right limb the level increase up to this mark, Okay, so now this is your ground level. Okay, this is the ground level. Okay, so this angle is a theta. This angle is a theta. Okay, so now we can consider it. This P2 means pressure at this point. Okay, means at this liquid level and this liquid level, both the same. So that's why I have joined the reference line. Okay, because these 2 points, the liquid level same. Okay, so you have to measure this one. This difference. You have to measure it. Okay, so how to measure it? Because first you have to measure the length. You can easily measure the length, this length of the level, how much rises this length, you can measure using the scale. Okay, so if you know the length value and if you know the value of the theta, right, if you know the value of the theta, so using the trigonometric, so you can value indirectly the h easily. Okay, so h equals to what? H equals to L into sine theta. H equals to what? L into sine theta. Because you know the value of L, if you know the value of theta, that is 60 degree, 30 degree, 45 degree, whatever. Okay, the angle. Okay, so you can calculate the value of the H. You can easily get the value of the H, right? You can get it. So now if you know this height, that is H1. If you know this height is H1 and you have calculated the value is H2. If you have calculated the value is H2, right? So what is the formula? How you will calculate the value of the pressure? So at this point, that is P1, that is the pressure applied, plus H1 into rho into G. Okay, so rho means what? The density of the liquid or gas, whatever you are applying service. Okay, so that is the rho density. That is equals to 0 means that is the P4. Actually, it is open to the atmosphere. This limb is open to the atmosphere. So we may consider, so that is 0. Okay, 0. So that is 0. So 0 equals to 0 plus H2 into rho m into G. H2 into rho m into G. This is your H2. Okay. So now rho m means what? Rho m means the density of the manometric fluid. Density of the manometric, already the manometric fluid is there, already it is available in previous law, because already in the case 1 already manometric fluid is filled first, then the liquid is applied. Okay, so this is the rho m is the density of the manometric fluid. Okay, so now if we calculate the H2, then you can easily calculate the value of the P1, that is the exert pressure you can calculate it. Clear? Now is it clear?
Yes, sir.
Okay, so now see, in this inclined type manometer actually, This is the single type inclined type manometer. Okay, actually in this case we are using the double type inclined type manometer, double limb. Double limb means there are two limbs are there, one limb and another limb, first limb and this limb. Okay, now what is the single limb? Single limb is first limb is transformed into a reservoir. So whenever it is transformed into any reservoir is a large cross-sectional area. Okay, the first limb is transformed into the reservoir. Okay, so reservoir means there is a large cross-sectional area. So that is converted to double limb to single limb. Okay, double limb to single limb. So that is the structure of the single limb inclined type manometer. So now what is the advantage again over the single limb inclined type manometer over the double limb inclined manometer? Okay, what is the advantage of single limb inclined manometer over double limb inclined manometer? See, in the single limb manometer, that is actually as there is a large cross-sectional area, so when the pressure is applied, so we do not see too much difference in the height in this case. Okay, so it may assume is a negligible. This height is a negligible. You can consider it. Okay, it will not too much vary. Okay, not too much. 1%, 2% vary. So it is like negligible. Okay, so we will look onto the right limb height only. We will not measure. In the single limb height. We will only look into the right limb height only. Okay, only the right limb height we will measure how much height level, how much of the level rises. Okay, so that thing is the single type inclined type manometer, single inclined type manometer. See, in this case, what you have calculated, P1 equals plus H1 into rho into G. But in this one double limb. But in case of the single limb, we will neglect this H1 because this limb already it is transformed into a reservoir. Okay, reservoir is a large cross-sectional area. So as it is large cross-sectional area, so whenever the pressure is applied, the height is very negligible. Difference is very negligible. H1 is very negligible. Change हो सकता है, fraction change हो सकता है, very small amount. So it is negligible. Okay, so we will not measure this H1 in the height area. We will not measure it. So directly we will go for the H2. Okay, directly we will go for the H2. So what will be the equation in the single limb case? So P1 equals to, directly we can write H2 into rho m into G. H2 into rho n into G. Right. So if you know the value, again the L. So under the angle of theta. So in same case, you can find out the value of H2. So H2 equals to L sin theta. So L sin theta into rho into G. So that is the main difference. That is the main difference between the single type and the double type manometers. Okay. So and this is the advantage of the inclined type manometer, single or double inclined type manometer over the vertical type U-tube manometer. Is it clear? Now is it clear?
Yes, sir.
It is a very important topic. Okay, if you it is basically mostly it is used in a mine. If you see in the mines that they are using the inclined type manometer, because in the case of the they may use the single type or double type, also as per the requirements. Okay, requirements. So basically inclined type manometer is used. So basically it is preferred in industry. That is why it is the advantage. Because in the vertical type manometer, height difference is very small. Okay, suppose the height difference is very small, then how will you measure the height? Then if you can't measure the height, then how will you go for the pressure measurements? So it is very difficult. Okay, you will be getting some inaccurate results. So to provide the accuracy, to better satisfactory performance, then you have to you have to incline the one limb. The one limb should be inclined. So whenever the one limb should be inclined, the level first you can find out the level. This length you can find out this length. Okay. So accordingly, using trigonometric formula, you can find out the H indirectly. So whenever the incline, this level is gradually decreased. Suppose 60 degree, 45 degree, 30 degree. So accordingly, your level of the fluid increases. Okay, so that will be providing the better results. Okay, so this is the actual main difference between the inclined type manometers over the U-tube manometer. Very, very important topic. Okay, very, very important topic. I will give you the one numerical also inclined tube manometer in the next class, whatever. Okay. So today I discuss the theory questions. In examination, that numerical or problem, numerical and theoretical questions also make up. In interview, actually, it is mostly used. Interview, okay. Interview, if you go for a technical interviews, okay. If you give some preference subject choice, okay. And if you if you face in a code interview, code technical interview, so definitely you face this type of questions, that what is the main concept difference between the single type and double type, singleton double type inclined manometers. Okay, the first questions may be asked. Another questions in practical real life that you have seen the inclined manometers is have seen that is in mines that it is used in inclined type manometers. Okay, because this is the advantage. If you use the vertical type manometer, so there's a disadvantage. You can measure the height difference perfectly. Okay, it's a very small height difference, and you can measure it perfectly. So if you use the inclined, if you erase the inclined, so obviously you'll be getting the perfect results. Okay, so that is the very important question, relevant questions. Okay, inclined type manometer, U-tube manometer, single type, and double types of inclined type manometers. Fine. So next thing is that ring balance type manometer. You know, ring balance type actually it is not too much important. Actually, another one is that inverted bell type manometer. Mostly important is that basically U-tube and the inclined type manometer. Ring balance type and inverted bell type is not part of your course. Okay, but actually these two types already for these two manometers fall under the category of the manometer classification. So that's why I'm saying that discussing what is the ring balance type manometer. Okay. So ring balance type manometer actually, if you see this diagram now, so this diagram actually case 2. This diagram actually case 2. So first you should actually understand that what is the case 1. Case 1, this first thing you have to draw. I am drawing the ring balance type manometer in the first case, initial case. Okay, initial case. So this is basically ring balance type. This is on ring. Okay, this is a hollow type. This is a type ring. Okay, and another the inner radius. Okay, there is a ring. This is another, because there are two pressure channels, one for the pressure 1 and pressure 2. Okay, that's you can measure the pressure difference. Okay, that's you can measure the pressure difference. So this is the this is the hollow type of rings. Okay, so actually here basically it is in straight position. Okay, this try to imagine it is in straight position. It is fixed straight position. Okay, so now it is in rest. Okay, because no pressure is applied in initial case. Fine. So there is a pointer. There is a pointer, and there is a indicating meter. Through this, you can measure the differential pressure. Okay. So here some pivot is there and a counterweight. There is some counterweight is there. Okay, this is a counterweight. Okay, it is attached with it. Counterweight is attached with it. Okay, and this is the actually cross-sectional area. This area actually cross-sectional area of the tube. Okay, so actually there are two pressures. One is the P1, another one is the P2. This is one. This is for the P1, and this is for the P2. Okay. So basically, actually, the ring balance type manometer consists of actually this is a hollow ring. Okay. So first, initially, that is a half filled. Okay. This is a half filled manometric fluid. We have filled half. Okay. In the manometric fluid, is filled half. Okay. In this ring balance type manometer first. So now, actually, the pointer here and the counterweight. So that is fixed and that perpendicular. You will see that here pointer and this weight is a perpendicular. Okay. To this bar. Okay. So there are two pressure inlets. One is the pressure 1, another one is the pressure 2. So it is very simple operation. This is a case 1. So when the no pressure is applied, so P is 0. So then what will happen? When the P is 0 means the no torque experience in this ring. No torque experience in this ring. So therefore the pointer will not move. Okay, pointer will not move. It will not indicate. So it will indicate only this 0%. It is indicate only the 0% because it will not move because the pressure is not applied. Pressure is not applied. Okay, so no torque experience. So now when the pressure applied, suppose P1 greater than P2. Suppose the P1 greater than P2. When the pressure is applied, then what will happen? Now see this diagram. When the pressure is applied, P1 and P2, then what will happen? The ring tilts in one direction. Okay, it will rotate. I mean, tilts. It tilts in one direction. Okay, because the torque experience in it. Because the torque experience in it. P1 greater than P2. Okay, so now it causes some differential pressure. Okay, so now the pointer already is attached with it. Okay, so then the pointer will start moving, or this side or this side will start moving. Okay, so now you can measure the pressure difference using this ring balance type manometer. Now understood? What is the working of ring balance type manometer? Understood?
No, sir.
Understood? There is
Sir,
a ring
is it
balance time manometer.
accurate, sir?
Is it accurate means actually it is used for the laboratory purpose. Okay, less than 1 minute. Okay, please join and use the same credential. Actually, it is ring balance time manometer is not too much accurate. Okay, because there is a counter weight is there and there may some vibrate also. Okay, in the if you for any experiments in the laboratory, so you can see there that they may vibrate. If it vibrates, so vibrates means that it may cause some noise, some interference. Okay, so you can say that you cannot say that it is too much accurate. Okay, you will be getting the results differential pressure, but it is not used, it's not preferred. Okay, so there is actually laboratory based instrument, the ring balance time manometer. Saying actually in our lab also, if you have visited in our lab, control instrumentation lab in last semester, I think that you have performed few experiments in our control and instrumentation lab. Have you visited our lab, CNI lab, control instrumentation lab?
No, sir.
Yes, is it?
No.
You have
No, sir.
last semester that you have subject measurement and instrumentation, measurement, electrical electronic measurements like that.
Yes, sir. We had that was in downstairs, like downstairs. We had it. Yes, sir. Measurement lab was there.
Yeah, measurement lab means you can in our department, electronics department,
Yes,
right?
sir. Yes, sir. Yes.
Yes.
Just with
So that is the
department.
so that is the control and instrumentation lab. Okay, you have performed the display control and you have a control and instrumentation lab that are laboratory based. We have two types of instruments available manometer. One is that U2 manometer, another one is that ring balance time manometer. Okay, so because this time it is not possible to show you the ring balance time manometer manually and the hardware because it's not possible in this situation. Okay, so that's why we're unable to show it. So if the university that opens, then you can come in your free time in our lab. Then we can show the ring balance time manometers. Understood? The basic working or ring balance time manometers. You can perform the experiments also. No issue. Okay. Understood? Clear? So these are basically the laboratory-based instrument. So that's why it is not too much used in the industry purpose. And the next thing, this is the last one, that is the inverted actually bell type, inverted bell type manometers. Actually, inverted bell type is that. See, first I am first sketching it. Please wait for a few minutes. Then I'll explain. Okay. I will go in the slide. Okay. Please wait. This is the chamber. This is the chamber, and you know that this is liquid. And suppose inverted bell, that is inverted. There is an inverted bell. Okay. And suppose there is a very liquid, some liquid filled is there. Suppose in this level we have filled some liquid. Okay. And this channel is open. This channel is open and another channel should open. Another channel should open. Okay, the pressure inletting point that is considered, that is a P1, and this thing is this pressure inlet, that is a P2, right? So now it is attached to, suppose, a spring. There is a spring. Okay, there is a spring, and this is a spring. Actually, it is the translation movement. Okay, this is a translation movement due to the spring. It converted the translation movement. Right? And a pointer is attached with it. Pointer is attached, okay, and it basically displays the pressure. Okay, pressure. So actually, this is the inverted bell. You will see that this is actually the inverted bell. Okay, this is the inverted bell. Inverted bell means just opposite. Okay, so opposite. That is the inverted. The opposite. So this is loaded actually by the spring. This is the spring. Okay, and on the top. Okay, on the top. So actually now weighing the pressure difference means P1 and P2. Weighing the pressure differential pressure. This inverted bell makes the translation movement. Okay, translation movement. So this translation movement, this displacement actually, that is converted to the pointer movement. And when the pointer will start moving, then what will happen? It will indicate the pressure. You will be getting the pressure. Right. So actually what has happened? So this is the two pressure line is there, low pressure line and high pressure line is there. Okay, this is the low pressure line and high pressure line is there. Okay, so when the P1 greater than P2, suppose you have considered the P1 greater than P2. So here the pressure, high pressure is applied in this channel. The high pressure is applied. Okay, so then what will happen? What will happen? it will force the bell. Okay, it will force the bell to move down. Okay, it will force the bell to move down, but due to the spring, it is attached to the spring, so it will move up. Okay, it will move up, oppose the movement, oppose the spring. Basically, what is the function of the spring? Because there is spring, oppose the movement. Okay, so upward force and downward force acting on this bell. Okay, so one the upward force and one the downward force that is acting on this bell. Okay, so what we can see, the upward force, what we can write, upward force means Fu, that is equals to what? That is equals to P into A. P into A means differential pressure. That means P1 minus of P2, P1 minus of P2, okay, into A. A is the cross-sectional area. A means what? A is the cross-sectional area of this bell, okay. So what is the FD? What is the FD? Downward force, what you can say, the downward force? Downward force equal to K into what? Del X. K into what? Del X. K means what? K is the spring constant, and del X means what? Del X means displacement. That displacement, okay. That displacement, that is that X, del X. Okay, we can see K into X or K del X. That displacement, translation movement to displacement. So that is the X. Okay, displacement of the bell. So under the equilibrium condition, what we can write? Under the equilibrium condition, what we can write? So that is Fu equals to Fd. Okay, Fu, that is equals to Fd. Upward force equals to downward force. Upward force equals to downward force. So K into del X equals to P1 minus P2 into A. K into del X equals to P1 minus P2 into A. So you can establish a relation, that is del X. Okay, del X proportional to P1 minus P2. So del X proportional to P1 minus P2, you can establish this relation. What is the meaning of this relation? Meaning of the relation is the translation displacement, this translation movement, that is proportional to differential pressure. माने जितना differential pressure हो रहा है यहाँ पे, जितना high pressure line, low pressure line में pressure difference हो रहा है ना, तो उतना translation movement हो रहा है यहाँ पे. And spring क्या कर रहा है? As it is loaded in the spring on the top, so it opposes the movement. So you know the concept. So that is the upward force and downward force already acting on the inverted bell. Upward force and downward force acting on the inverted bell. So you can say here the upward force equal to downward force. Upward force equal to downward force. Upward force means upward this pressure into area. That is the upward force. And downward force means due to the spring actually. So that is the K into del X. K is the spring constant we know, and del X is the movement, this translation movement. So under the equilibrium condition, what we can establish the relation, that is the del X, Fu equals to Fd. So if you equate this equation, this term, then we can establish the relation, that is del X proportional to P1 minus P2, means del X proportional to del P. So if translation movement, that is proportional to that differential pressure. So that is the inverted bell type of manometers. Clear? Clear what? Ring balance, inverted bell type manometer. Is it clear? Yes. Okay. So this is actually the overall of manometers. Okay, overall manometer, that is the U-tube manometers, inclined type manometers, vertical type tube manometers, just single type, double type inclined manometers, okay, ring balance type manometers, and the inverted bell type manometers. Okay, so actually ring balance type and the inverted bell type was not part of your course, but as it is the laboratory based instrument, okay, and the ring balance type already available in our lab, so that's why I have included these two topics. So that's why I have discussed, okay, ring balance and inverted. But most important is that inclined type manometer, single and double limb inclined type manometer is the most important. And today I am saying that one problem will definitely come from the inclined type manometers. I will give you one examples. You can solve it. Okay, in the next class I will give you one examples how to solve the inclined type manometer for different application based on different service. Okay, typical service. How you measure the how you measure the pressure, exit pressure. Okay, so I will give you an examples. You can calculate for practice. Okay, you can practice for that. So one numerical. Okay, so the topic.